Hello to everyone, this is Vishal, and now we have another session of the day that is related to your Rxjava. And as the sessions be going on related to the Rxjava, and we have done 5 to 6 tutorials on that, we learn observable types and the retrofit calls with Rxjava, and how we can do that callback with the observables on your server, that's your web server, and by the retrofit on my recent tutorial. So these kind of stuffs be going on, and we are working on more deep on Rxjava and async task class, that alt class. We are refused to use that in my coming sessions. On my last tutorial I told you that instead of using that async task you have to work with the Rxjava, and at that time I described to you that how it's working, but how we can achieve that using the ObserveOn and SubscribeOn, and which kind of schedulers we are using with that. So that's the important task for the day. But we have to learn that related to that operators, and operators be here your SubscribeOn and ObserveOn. So let's discuss about that. So as we can see that where we have a main thread or maybe a background process, it depends on the schedulers. And what is sync, what is async behavior, these all we have uh, already know about that, and we worked with that, but I'm discussing again today. So first I'm just clear to you that again what is the synchronous and asynchronous differences. So when we go with the synchronous differences, it's your execute something, and it's on the sequence manner, and once first one completed then we start the second one, and sometimes it's related to your uh, with the time. So that means uh, this is your abounding, so that's your synchronous way. And whenever you work with your asynchronous behaviors, so that means there is no kind of bonding between the tasks. That means you can do it freely. So the sequential behavior terms as synchronous, the execution which happens independently without interrupting the normal flow of the executions, is called asynchronous call. So we need asynchronous calls in our Android sometimes. So first we need to know about what is the behavior, Android behavior, and how it can operate. So everything that we run on the main UI thread runs on the synchronous manners. It means when you work with your main activity and you call something on your life cycle, you call the things from the retrofit or other. So that means once you get that data, then you come on the next stage. So sometimes we need a parallel task. We have a lot of data, and uh, maybe it take a time some data in loading. So that means on that cases we do not want to stay there on the main activity and don't want to hang on that. We need it on the background processes. So once it's completed, it worked and it showed to you. So that's kind of asynchronous behavior we need it. And related to this, we have one more term, as you already know about that, and many times it's a question in interview, what's the ANR? So that's your application not responding. So if we start doing long running task on the main thread, and then till that task is done, we can't do anything in that app, and our long running task is a blocking, and that creates sometimes a ANR because of it take a too much time. So Android throw the error, that's your not responding manner. So that's your dialog. So it's a good, we shift the long running task somewhere in a new thread from the main UI thread. So that's concept is your asynchronous. And the old way to achieve that that's your async task, that's your async classes be there, as we did on my previous tutorial, how we can call that class, do in background and your post execute manner. So what that do in background and post execute work, that means you call something on that, and on your post execute you show something on your main UI. So that means here, because of we do not use that approach, we are working with the reactive programming. So reactive programming is a very easier and powerful feature today because of you know that how to use that in a proper way, so you can do many things and you can solve many queries easily related to the async task or the other big task related to your web services or the database handling. So that's the way of reactive programming working. So as I um, read many Rxjava PDFs and uh, books. So on that scenarios, we can say that we can process the events, GPS signals. We'll upload more tutorials related to that. I will make a practical things and asynchronous behaviors of IO, handling events. So these kind of things. And today the best example we can give that Rxjava, that's for Netflix and Twitter that are working. So first important point is to know about the behavior of observable. So first we need to understand. So as we discussed that asynchronous behavior. So the Rxjava is default asynchronous behavior behavior. So in Rxjava, whenever you work with the reactive programming of Rxjava, that means you're working with your async task. But you will make it sometimes async behavior, but that depends how you can call that a synchronous way. But we'll make more we'll make a video on that. But today we just working with the async task, that means asynchronous behavior, that is separate. So whenever you're working with a network call, you retrieve some data from reward server, is it? And the network call is not asynchronous because of it takes some time, it takes some milliseconds, some take, and it depends on your network calls. That means which kind of network, which quality of networks you are working. So a lot of things be there. So here, if you are working with the old asynchronous way, that means memory leaks and multiple web services calling issues with that, orientation issues with that. But here the Rxjava, it's a very good because of we have a disposable. So that means it avoid the memory leaks as I discussed on my first basic tutorial. So how we can make a group of join and how we can these stuffs we with the Rxjava, I will make a video on that. I will share you that. But we have to discuss about the operators. So the basic things we learn that async task and sync task. Async behavior. So Rxjava is asynchronous. Okay, and in the asynchronous behavior we have to operate that. And I already described you in our old class of asynchronous. We have a doing background and a post execute way. So doing background is just like B. So here on Rxjava, how these two methods we work. So first we need to understand these operators. The first one is your observable and the second is your observe on, and second is your subscribe. Subscribe on specify the scheduler. Here today I'm working with subscribe on with the scheduler and your observe on with main thread. Okay. So subscribe on we specify the background thread on that case where the data flow be generated and processed. And whenever you want to show that, so that means it works with your main thread. So that's your observe on. I will make a small practical but not a much because of today is the day in which we have to discuss the theory well. On the next video tutorials I will show you the schedulers and these kind of things with the practically. But today just you have to learn because of you have to focus on that observe on and subscribe on, and with your async task or a sync task. So basically subscribe on is mostly subscribe on the background thread. You do not want to block the UI thread. Okay, and while your observe on, whenever you work on that, that's it show to your main thread. So that's your Android scheduler dot main thread. But sometimes we are working with ObserveOn schedulers, but I don't want to go today with with that. I'm just showing to you subscribe on, that's be working with the schedulers, and observe on, that's be working with your Android main thread. It just be like when you work with the schedulers, you have to work with like a background processes, and that scheduler depends on scheduler types. wherever you use the scheduler computations, IO, and your new thread. So you have to learn these kind of things, but first you know about the pooling, because of pooling is a uh, uh, we can say the technical term behind the scenes of schedulers. So these kind of things you have to learn. The first basic thing, asynchronous task. Asynchronous tasks, whenever we use, do not approach the old way. You have to use the Rxjava, and there we were working with that the old way approaches to in background, post execute, pre execute, lot of stuffs with there. So the same we have working be here with the operators, but in a new technical way and easy way and avoid the memory leaks. So subscribe is a similar to do in background method and observe on to in post execute as we are learning. So ObserveOn affects the thread that the observer will use below where the operator appears. And subscribe on operators designates which thread the observer will begin operating on. And the one more thing, we have to know about the downstream and upstream because of that's important way to work with the ObserveOn and the subscribe on. So one more thing you have to learn that because of we are showing the main thread. So that means it always be work with the downstream. The downstream means operator to your observer, and upstream means your operator to your observable. So that's the subscribe on be working on both the way, on your observable and your observer, while the observe on works with your downstream. So that means on the main thread it works with that, and sometimes with the schedulers also. So Rxjava, we can say Rx is a single threaded, which implies that an observable and the chain of operators so that we can apply to it will notify its observer on the same thread on which its subscribe method is called, as we discussed on my first tutorial. Okay, so ObserveOn and subscribeOn methods take an argument a scheduler. That is the name suggests. It is a tool that we can use for scheduling individual actions. And which kind of actions you are using, which kind of scheduler, it depends on your uh, app or your programming, what you want to achieve on that. And schedulers are the main components of Rxjava that I will discuss to you. But after this, so the first approaches we have done, that is async task and async task. And we do not go with that. We work with Rxjava with your operators, and operators be working like the same. And let me show you. So that's be if you're working with the source, this is your observable. This is your observable. This is the source. This is your operator any kind of, that is a subscribe on or observe on or both, and this is your destination, that's your observer. So that means this is upstream and this is downstream. So our subscribe on working with both the way, okay, and while our observe on working with only upstream, sorry, downstream. So that means whenever you want to show something, that means you need to show the observer on next or other. So you have to work with, that means on the main UI, because of Android works with your main UI, and we need to show the things after you get the things on by the your background processes. You have to show on your main thread, is it? So that's the way. So from top to the operator we call the upstream, from operator to the bottom we call the downstream. Subscribe and observe on only operators, and subscribe on affecting its upstream and downstream, while observe on affecting on downstreams. We'll discuss it on more practical way in my coming session, but today just you have to learn these points. Okay, so an operator is a function that takes and alters the behavior of an upstream observable and returns a downstream observable or subscriber. Is that? So that's general questions in Rxjava introduced, that what's Rxjava, what is reactive programming, what are the observe on, the subscribe on, and how they working, and what is your async task, sync task. So today is the day, and what are the scheduler types. So that I will make. So today is the day where we are working with these kind of deep things. And the one more thing we are working uh, that is your, because of it's an important which kind of schedulers we are using. So we need to know about the pooling. Pooling is a best way, that is we can say the mechanical way behind the scenes, because of as you know about the how the pooling works in a Java. So that's again I am talking about uh, when you use the scheduler, just like your IO or computation where we need it. It depends on your poolings, and poolings we work on your bounded and unbounded behavior, and that bounded and unbounded behaviors are much important whenever you work with the schedulers, is it? So just to discuss about that. So here, what is the pool? The thread pool is the collection of pre-instantiated standby threads and which are ready to execute application level tasks. And thread pools improve performance by running multiple tasks simultaneously. And at the same time, they prevent the time and memory overhead incurred during thread creation. So if you see these are this diagram, here we have multiple tasks and this is the queue of tasks. And these tasks be working with their separate threads, that's be thread 1 2 3 4 5. This complete scenario is called your thread pool, and once your thread 1 be worked and the first task be finished, so that's your task be going on. And if you're working with the sequence, so that means your synchronous behavior be there. And in asynchronous behavior, and under the asynchronous behavior, if you're working with the thread, so that means a multiple new threads or multiple IO or multiple computations we are working on that under the asynchronous task. Okay, so here we need to understand the bounded and unbounded behavior of the queues, because of they are working with the Rxjava schedulers. So queue can be bounded or unbounded. That means if you define some capacity of the queue, that means the size, so that's your bounded. And unbounded, that means where we do not want to go with the capacity, so that means free task you are working on that. And here with the size, so IO are working with the thread pools. Computations, that means where it is bounded or unbounded, where the IO bounded or unbounded. So that's the matter whenever you work with the Rxjava. So that I will make next video on in these complete things. So just the basic things today we are learned related to the task, that's your operators, and where the pooling works, that means on your schedulers, and what is your upstream and downstream, that's important. And the last scenario is your how we can use that operators with your bounded and unbounded behavior. So that's just showing to you which kind of task be working be here. I'm just make a small practical for you how the threads be run on that, and that we going on the deep on our next tutorial. Okay, so let us start a small practical on this. Okay, so let us start in Android Studio. Here we did last time this uh, imply results by the retrofit calls, but today I'm just showing to you how it works with the simple observable. So that's the thing we have to learn. Okay, so be here I'm using this observable dot just and put two values be like 1 2, and that at this time I subscribe on the scheduler with IO, and we'll describe where we use this IO or a computations or where we use the new threads. So a lot of stuffs be there in coming sessions, and just show to you how it works be here, which kind of threads we work here. So new uh, observer, and here you can see that on the next value you can see this is log.d, and here I'm using next, and this is your string s, And one more thing I am showing to you, that's your what's the current thread. So it works be only as subscribe on at this time, so that means it's working be upstream, next stream, and on the background thread. It's not with the process of UI main thread. Okay, so here current thread, and you can use this as a thread dot current thread dot get name. Very simple. So check it what happened here. So it's very interesting, but we have to learn the facts and a lot of technical things behind the scenes. That's very important whenever you work with any new component. So just describe you these things because of in future programs that's important. This basic knowledge. You click on that. So you can see that this is the R cache thread scheduler for the both the processes. So this is your current thread, and scheduler IO is always be your cached thread scheduler. Why it is, where we use it. So these I am uploading the next session soon, so you can learn that on where we use this scheduler. But here this operators. So now this is the first operator as we did it many times. But what's the use of the second operators? That means, as I told you today, I'm just showing to you how this works with the main thread. So this comes to your UI. That means it works now a part of the operator to observer. So that's important. So at this time it's run with that. So whenever you work with your lot of data be there and you get the things from your web server, you just make it like that. And we have I already discussed where we use the just, where we use the create and other things. So that's an important. And last time I described you, that is observable callbacks we have done. So here you can see that all comes with your main thread. That means the current threads be your main process. So that's a very simple scenario as we discussed today. The basic knowledge we have for the ObserveOn and the SubscribeOn, a little bit thread pooling. So these stuffs be on our next tutorials will be important. So uh, so I wind up for the day, but soon I will upload the next tutorial for the schedulers with the same. Okay, thank you so much.